Imagine a world cloaked in mystery, a rusty-hued enigma that has captivated humanity for centuries. Mars, our celestial neighbor, beckons with its stark beauty and secrets buried in its ancient sands. Its frigid, arid surface, draped in a thin atmosphere held by weak gravity, whispers tales of a warmer, wetter past, a time when rivers carved its valleys and life might have stirred in its depths. As we embark on this narrative journey, prepare to be drawn into the saga of Mars exploration, a story of relentless curiosity, technological triumphs, and questions that keep us gazing skyward. This is not just a tale of science, it's a human odyssey, one that invites you to wonder, engage, and dream of what lies beyond our world. If this story ignites your curiosity, hit that like button, share your thoughts in the comments, and subscribe for more cosmic adventures. The year is 1877, and Italian astronomer Giovanni Schiaparelli peers through his telescope, sketching what he believes to be the most accurate map of Mars to date. His drawings reveal linear features he calls canali, Italian for channels, sparking imaginations worldwide. By the early 20th century, American astronomer Percival Lowell seizes on these markings, declaring them evidence of a Martian civilization. Canals, he argues, suggest intelligent beings managing water on a dying planet. This bold claim ignites a global fascination, setting the stage for a quest that would span decades: the search for life on Mars. The idea of alien civilizations captures hearts and minds, but it's the Cold War that fuels the first tangible steps toward the Red Planet. Rival superpowers, the Soviet Union and the United States, launch probes in a race to uncover Mars's secrets, driven by both scientific curiosity and geopolitical ambition. In 1962, the Soviet Union's Mars M1 probe embarks on a daring flyby mission. It's an audacious leap, but the mission fails, a harbinger of the challenges ahead. Both nations face repeated setbacks, yet their rivalry propels innovation. By 1971, NASA's Mariner 9 becomes the first spacecraft to orbit another planet, a milestone in human exploration. But Mars guards its secrets jealously. A massive dust storm obscures the surface, revealing only a featureless red haze. Mariner 9, however, is equipped with a critical advantage: NASA's ability to command it to wait. Months later, as the dust settles, the probe unveils a landscape of towering volcanoes and vast canyons, rewriting our understanding of Mars. The Tharsis Plateau, home to the solar system's largest volcanoes, emerges from the haze, their peaks piercing the thinning dust. These ancient giants, dormant for billions of years, hint at a planet frozen in time, lacking the tectonic forces that reshape Earth. Fast forward to 1976, and NASA's Viking program marks a new chapter. Twin orbiters, Viking 1 and 2, carry landers to the Martian surface, delivering the first close-up views of a rocky, alien terrain. Their mission? To seek signatures of life. Equipped with 3 experiments, the landers probe the soil for signs of microbial activity, but the results are ambiguous. The experiments, limited by the technology of the time, fail to deliver conclusive evidence, and the scientific consensus leans toward a sterile Mars. Yet as researchers on Earth discover life thriving in Earth's harshest environments, deep sea vents, and Arctic ice, they begin to rethink where Martian life might hide. The dream of life on Mars doesn't die, it evolves, urging scientists to look deeper, beneath the surface, where liquid water might persist. The Viking missions also map Mars's geology, revealing a cratered landscape untouched by the dynamic forces that renew Earth. The absence of plate tectonics and the presence of colossal volcanoes like Olympus Mons, the largest in the solar system, tell a story of a planet that once pulsed with activity, but now rests in stillness. These findings guide future missions, pinpointing landing sites for the next wave of explorers. The Viking era, though inconclusive on life, lays the groundwork for a new age of discovery, proving that Mars is a world of complexity and untapped potential. After a 20-year hiatus, Mars exploration roars back to life in 1996 with NASA's Mars Global Surveyor. Its high-resolution images reveal a planet sculpted by ancient rivers and deltas, their channels etched into the surface like scars of a lost era. These features, pockmarked by impact craters, suggest that liquid water hasn't flowed for billions of years, yet their presence rekindles hope. Could Mars have once been a cradle for life? The question lingers, driving the next mission, Mars Pathfinder, launched in 1997 under NASA's faster, better, cheaper philosophy. This mission introduces a groundbreaking landing technique, airbags inspired by automotive safety systems, allowing the Pathfinder to bounce to a safe stop in Ares Vallis, a rocky region shaped by ancient floods. Pathfinder deploys Sojourner, the first rover to roam another planet. This pint-sized explorer, equipped with cameras and an alpha particle X-ray spectrometer, captures thousands of images and analyzes the Martian soil. Its findings, relayed through a base station with solar panels and weather sensors, confirm a diverse geology shaped by water. The mission's success, amplified by its own website, a novelty at the time, captivates the public, ensuring more missions to come. Pathfinder's triumph proves that small, innovative missions can yield big results, setting the stage for a new era of robotic exploration. In 2001, Mars Odyssey launches, equipped with instruments to study the planet's surface and atmosphere. Using a novel aerobraking technique, skimming the upper atmosphere to save fuel, it settles into orbit, becoming the longest-serving Mars mission as of August 31st, 2025. Its data confirms water ice in the polar caps and maps the planet's geology in unprecedented detail. Odyssey also serves as a relay for future surface missions, strengthening the link between Mars and Earth. In 2003, the European Space Agency enters the fray with Mars Express, its first planetary mission. Though its Beagle 2 lander is lost, the orbiter thrives, delivering 3D images and detecting methane and ammonia in the atmosphere, gases often linked to life. These findings spark debate. Are they produced by geological processes or something more tantalizing? Mars Express, extended through at least 2020, continues to unravel the planet's mysteries, its stereo camera painting a vivid picture of a world shaped by ice and wind. January 2004 marks the arrival of NASA's Mars exploration rovers, Spirit and Opportunity, landing on opposite sides of Mars, Spirit in Gusev Crater, Opportunity in Meridiani Planum. They use Pathfinder's airbag technique to touch down safely. These rovers, far more advanced than Sojourner, carry abrasion tools to grind into rocks, revealing their composition. Opportunity's discovery of stratified rock patterns and chlorine-bromine distributions in Meridiani Planum confirms that liquid water once flowed there, perhaps as a salty sea. Spirit, meanwhile, uncovers olivine-rich rocks in Gusev Crater, akin to Earth's volcanic basalt, and later finds salt deposits formed in hot water, an environment where microbes might thrive. Despite challenges, Spirit's wheel failure, and Opportunity's eventual dust-clogged demise in 2018, the rovers exceed expectations, operating for years instead of months. Their longevity is aided by Martian winds that clear dust from their solar panels, a serendipitous gift from the planet itself. These missions transform our view of Mars, proving it was once a wetter, potentially habitable world. Their legacy endures, inspiring future explorers and captivating audiences worldwide. Want to share your thoughts on these incredible rovers? Drop a comment below and let's discuss. In 2008, the Phoenix lander targets Mars' northern polar region, where Odyssey's data suggests subsurface ice. Using a parachute and thrusters, Phoenix lands gently, avoiding the contamination risks of previous bounce landings. Its robotic arm digs into the soil, uncovering water ice that sublimates when exposed. The lander's meteorological station records snow and cirrus clouds, painting a picture of a dynamic polar atmosphere. However, the presence of perchlorate, a bacteria-killing compound, tempers hopes for life. Phoenix operates for 5 months, outlasting its planned 90-day mission, before winter's shade silences its solar panels. In 2012, NASA's Curiosity rover arrives, a car-sized marvel powered by a nuclear battery, immune to dust storms. Landing in Gale Crater via a daring sky crane technique, Curiosity is a mobile laboratory, drilling into the Martian soil to analyze its chemistry. It finds sulfur, nitrogen, hydrogen, oxygen, phosphorus, and carbon, elements essential to life. Curiosity's self-portraits reveal wear on its wheels, but as of August 31st, 2025, it continues its 20-kilometer journey, beaming back data on radiation levels critical for future human missions. Its discoveries in Gale Crater, formed 3.5 billion years ago by water and wind, suggest Mars once harbored conditions suitable for life. The question remains, could life still lurk beneath the surface? In November 2018, NASA's InSight lander touches down in Elysium Planitia, near the equator. Its mission is unprecedented, to study Mars' interior, equipped with a seismometer to detect Mars quakes and a thermal sensor to measure heat flow from the planet's core. InSight seeks to understand why Mars evolved so differently from Earth. By August 31st, 2025, it has spent nearly 2 years probing the planet's geological activity, revealing a world that was once warm and wet, but now lies cold and dry. These insights into Mars's core and crust help us piece together the planet's history, offering clues to its transformation from a potentially habitable world to the desert we see today. The quest for answers on Mars takes a bold leap forward with the Mars Sample Return mission, a collaborative effort between NASA and the European Space Agency progressing as of August 31st, 2025. Launched in the early 2000s, this ambitious project aims to collect and return Martian soil and rock samples to Earth for detailed analysis. NASA's Perseverance rover, which landed in Jezero Crater in 2021, has been diligently gathering samples, caching them for a future spacecraft to retrieve. These samples, rich with potential clues about Mars's ancient climate and possible microbial life, represent a historic milestone, the first time material from another planet will be studied in Earth's laboratories. The mission's complexity, involving multiple spacecraft and precise orbital maneuvers, underscores humanity's determination to unlock Mars's deepest secrets. Imagine the moment when scientists crack open these samples, perhaps finding traces of ancient life. What would that mean for our place in the universe? Share your thoughts in the comments, and let's ponder the possibilities together. Beyond robotic explorers, Mars stirs dreams of human footsteps on its dusty plains. As of August 31st, 2025, plans for human missions to Mars are advancing, with NASA and private companies like SpaceX outlining bold visions. NASA's Artemis program, focused on lunar exploration, serves as a stepping stone, testing technologies for Mars missions in the 2030s. SpaceX's Starship, designed for interplanetary travel, aims to make Mars colonization a reality, with Elon Musk targeting crewed missions within the decade. These plans hinge on overcoming daunting challenges, protecting astronauts from cosmic radiation, developing sustainable habitats, and ensuring safe landings on Mars's rugged terrain. Curiosity's radiation data and InSight's geological insights are critical, informing designs for future missions. Picture astronauts exploring Gale Crater, drilling into its ancient sediments, or studying the polar ice caps up close. The prospect of humans on Mars isn't just science fiction, it's a future we're building. What excites you most about humans on Mars? Drop a comment and let's dream big. Mars exploration is more than a scientific endeavor. It's a mirror reflecting humanity's aspirations and resilience. Each mission, from Mariner 9's patient wait through a dust storm to Perseverance's sample collection, teaches us not just about Mars, but about ourselves. The Red Planet's story, its lost rivers, frozen oceans, and silent volcanoes, parallels Earth's own journey, urging us to cherish our fragile world. As of August 31st, 2025, Mars continues to challenge our assumptions, with missions like China's Tianwen-1 rover and the UAE's Hope orbiter adding new perspectives to the global effort. These international collaborations highlight a shared human drive to explore, uniting nations in pursuit of knowledge. Mars reminds us that exploration is iterative. Each answer spawns new questions, pushing us to innovate and persevere. How does Mars inspire you to look beyond the horizon? Hit that like button, share your thoughts below, and subscribe to join the cosmic conversation. As the 21st century unfolds, Mars becomes a global stage for exploration, with nations beyond the US and Europe joining the quest. China's Tianwen-1 mission, launched in 2020, marks a significant milestone, combining an orbiter, lander, and rover in a single endeavor. By August 31st, 2025, the Zhurong rover, deployed in Utopia Planitia, has traversed the Martian surface, analyzing soil and searching for signs of water ice, while the orbiter maps the planet's atmosphere and relays data. The United Arab Emirates Hope mission, also launched in 2020, orbits Mars, studying its weather patterns and atmospheric dynamics. These missions, alongside contributions from India's Mangalyaan orbiter, which confirmed methane in Mars's atmosphere, reflect a growing international commitment to unraveling the planet's mysteries. This global collaboration not only diversifies our understanding, but also fosters unity in a shared pursuit of knowledge. The data from these missions, freely shared among scientists, builds a richer picture of Mars, sparking debates about its past habitability. What do you think about this global race to Mars? Share your excitement in the comments below. Behind every successful Mars mission lies a symphony of engineering ingenuity, pushing the boundaries of human capability. From the airbag landings of Pathfinder to the skycrane precision of Curiosity, each mission introduces innovations that redefine space exploration. As of August 31st, 2025, NASA's Perseverance rover showcases cutting-edge technology, including MOXIE, an experiment that converts Martian carbon dioxide into oxygen, a potential game changer for future human missions. The rover's ingenuity Ingenuity helicopter, the first powered aircraft to fly on another planet, has logged dozens of flights since 2021, proving aerial exploration is possible in Mars's thin atmosphere. These technological leaps, born from decades of trial and error, address challenges like extreme temperatures, dust storms, and communication delays across millions of kilometers. Engineers at NASA's Jet Propulsion Laboratory and international agencies work tirelessly, testing designs in simulated Martian environments on Earth. Their successes inspire awe, but their failures, such as the Mars Climate Orbiter's loss due to a metric conversion error, teach humility. What engineering feat amazes you most? Let us know in the comments and join the conversation. Mars has transcended science to become a cultural icon, shaping art, literature, and our collective dreams. From H.G. Wells' War of the Worlds to modern films like The Martian, the Red Planet has long symbolized humanity's hopes and fears about the unknown. As of August 31st, 2025, Mars missions continue to inspire creators, with virtual reality experiences letting people walk on its surface and music celebrating its stark beauty. The discoveries of water ice and potential biosignatures fuel narratives of human survival and exploration, while the planet's harsh realities remind us of Earth's fragility. Public engagement with missions like Perseverance, amplified by social media, has made Mars a shared adventure, with millions following rover updates in real time. This cultural resonance drives funding and support for space programs, as people see Mars not just as a destination, but as a reflection of our potential. How has Mars shaped your imagination? Share your favorite Mars-inspired story or media in the comments. Like this video and subscribe for more cosmic tales. Our journey now takes us beyond Mars to Saturn, a gas giant 100 times Earth's mass, adorned with rings that have fascinated astronomers for centuries. Viewed from Earth, these rings appear as a faint band, their true nature unclear until mathematical analysis revealed them as orbiting particles of ice and dust. But why does Saturn alone boast such splendor? The answer lies in a series of missions that transformed our understanding of this ringed world. In 1977, NASA seizes a rare planetary alignment to launch the Voyager probes, part of the ambitious grand tour to visit the outer planets. Preceded by Pioneer 10 and 11, which brave Jupiter's radiation and Saturn's rings, the Voyagers reveal a complex system. Voyager 1 discovers the G-ring and transient spokes in the rings, while Voyager 2 captures detailed images of Enceladus, a moon with an icy, uncratered surface hinting at a subsurface ocean. These flybys, though brief, overwhelm scientists with data, raising as many questions as they answer. In 1997, the Cassini spacecraft launches, a collaboration between NASA, ESA, and the Italian Space Agency. Arriving at Saturn in 2004, Cassini orbits the planet using Titan's gravity to adjust its path and study the moons and rings. Its Huygens probe lands on Titan in 2005, revealing a geologically active world where liquid methane and ethane carve rivers and lakes. Cassini's 24 passes by Enceladus uncover plumes of water vapor, salt, and organic compounds, suggesting a liquid ocean beneath its icy crust, a potential haven for life. By 2017, Cassini's fuel dwindles, and it embarks on daring, ring-grazing orbits, sampling particles and gases before plunging into Saturn's atmosphere to avoid contaminating its moons. Its final data, transmitted on September 15, 2017, reveals a ring rain of 10,000 kilograms of ice and dust per second, predicting the ring's demise in 100 million years. Our cosmic voyage concludes at Jupiter, the solar system's largest planet with a mass dwarfing all others combined. Its swirling bands and Great Red Spot, a storm larger than Earth, have intrigued observers since Galileo Galilei's telescope revealed its moons in 1610. These moons orbiting Jupiter challenge the Earth-centric view of the universe, setting the stage for centuries of exploration. In 1972, Pioneer 10 braves the asteroid belt to reach Jupiter, revealing intense radiation that forces last-minute shielding for the Voyager probes. Launched in 1977, Voyager 1 and 2 unveil a dynamic Jupiter with Io's volcanic plumes and Europa's icy, ocean-covered surface. The Galileo spacecraft, orbiting Jupiter from 1995 to 2003, confirms Europa's subsurface ocean and Io's extreme volcanism despite battling radiation-induced failures. In 2016, Juno arrives, its solar-powered design and polar orbit offering a new perspective perspective. Juno's images reveal chaotic polar storms and a magnetic field unlike Earth's, hinting at an atmospheric source. Its mission, extended through at least 2025, continues to probe Jupiter's composition, offering clues to the solar system's origins. As we reflect on this journey, Mars, Saturn, and Jupiter emerge not just as planets, but as chapters in humanity's quest to understand our place in the cosmos. Each mission, from Viking's tentative steps to Cassini's final dive, has pushed the boundaries of what's possible, revealing worlds both alien and familiar. Mars's ancient rivers, Saturn's shimmering rings, and Jupiter's stormy grandeur remind us that the universe is vast, complex, and brimming with possibility. Could life exist in Europa's ocean or Enceladus's depths? The question lingers, urging us to keep exploring. This story isn't over, it's just beginning. New missions, like NASA's Europa Clipper, set to launch in 2024, promise to delve deeper into these mysteries. As of August 31st, 2025, no missions to Saturn are scheduled, but the data from Cassini continues to inspire. Share your excitement for space exploration in the comments. Like this video to support our cosmic journey, and subscribe to stay updated on the next chapter. Together, let's keep reaching for the stars, uncovering the secrets of our solar system, one mission at a time.